Okay, hello, good afternoon, everyone. Happy Saturday. Welcome back to our November week 3 lesson. All right, so what are we doing today? Today we are doing revision for chapter 9, okay, which is this one. All right, so this will be a two-part revision. So today we will be doing first half of the revision, and next week we'll be doing the second half. All right, so chapter 9, form 4. This chapter has 3 parts, which is your alloy. Okay, if you still remember what your alloy is, it's a mixture of 2 different metals, 2 or more types of metal. Okay, that's your alloy. So we have our alloy as our first part, and then second we have glass and ceramic. Okay, glass and ceramic, and then the third part we have polymer. Okay, polymer. If you still remember what is it? It's when you combine monomer. Okay, a single unit is called monomer. When you combine many monomers together, you will get a polymer. So in this case, you have your plastic and you have your rubber. Rubber will be our concern. So this is next week. All right. So today let's begin with alloy. Okay, alloy. This is a very important part. Okay, every year SPM alloy is going to come out. You have my guarantee. Okay, you have my guarantee. Alloy is every year. If you do the past year, every year, I don't care whether it's chapter 1 or sorry, in paper 1 or in paper 2, alloy is like a for sure coming out part. Right, so what is alloy? Alloy is a mixture of several types of metal. Okay, campuran beberapa jenis logam. Okay, or it's a mixture of metal and non-metal. Okay, whatever lah. Okay, the key point here is several types of metal. So why do we do alloy? Okay, first of all, the process of making alloy is called alloying. Okay, in BM is pengalloyan. Okay, pengalloyan. Yes, hello, Wayne. All right, we just started. Okay, we are in page. What was this page again? This is page 3. It is page 3. All right, so alloy. The process of making alloy is called alloying. So why make alloy? Because you see, first of all, pure metals they are soft. Okay, lembut, and they will corrode. Okay, menghakis. We make alloy to solve these 2 problems. This is why if you look at alloy, they are harder, increase hardness, meningkatkan kekerasan, and prevent corrosion, mengelakkan hakisan. That means if you use iron will rust. But if you use steel, galuli, this thing, not to say it won't rust, but it will rust much slower. So since it rusts much slower, it will improve the appearance. It makes it more attractive for longer. So this is why we don't use pure metal. All right, so there are 5 types of alloys here. Okay, you have your steel, galuli, pewter, bronze, which is gangsa, okay, brass, which is loyang, and of course duralumin. Okay, alumin, you know this is aluminium. Okay, so let's look at steel first. Okay, steel is made from iron and carbon. Can you see the percentage here? Should you memorize? No. The percentage is not your concern. Even the composition, sometimes they won't ask. Okay, iron and carbon, they won't ask. So if you have no time for it, you are too lazy, you can just memorize the use. Okay, because use is the most common one. So properties, they're hard and strong. Use, they are used for construction, pembinaan. If you have a place you need to use a lot of iron, you need to use a lot of metal. For example, your car. Your car is made from a few 100 kilograms of metal. I mean, you can use other alloy, no problem, but it will be too expensive. So if you need something that is cheap and strong, you would use steel because it's very cheap. That's why a lot of metal tools, a lot of structures, okay, like your buildings, they're made from steel because they're very cheap. Okay, to make the frame of vehicles and the railway track. You see, railway tracks, your landasan kereta api, you need a lot of metal for it. This is why we use steel. Okay, because it's cheap. Okay, next, pewter. This thing has not much use. This is your tin. Tin is your timah. You know, biji timah. The thing is your tin. So it is shiny. So we only use it for one thing, which is decorative item. We have not much use of pewter nowadays. Last time, The British, they use tin for food can, okay, tin can. But now we don't anymore. Okay, we just use aluminium. So this filter has not much use already. Okay, it is used as decorative item. So bronze and brass, okay, I'll put these two together. Okay, these two they are the most common alloy in exam. Okay, whenever exam you see alloy question, chances are 90% of it is going to be bronze and brass. Okay, so these two, you should memorize the composition, not the percentage. Okay, bronze is made from copper and tin. Brass is made from copper and zinc. So the difference is the zinc and the tin. The main ingredient is still the same. They are both made from copper. They are both cousins of copper. The difference is bronze is kind of yellowish brown. Okay, the color. If you look at bronze medal, brass they look yellow. Okay, they look yellow. So what's the good point? Okay, they are attractive. Okay, they are shiny. So this is why bronze is used to make monuments, sculpture, coins, and medals. Okay, even statues. You know, Statue of Liberty, the one in the US, the thing is made from bronze. Okay, it used to look bronze color, as in it used to look reddish brown, but now the Statue of Liberty is green because it is oxidized. Okay, when you oxidize bronze, the thing will turn yellow. The thing will turn bluish green, which is the color of the Statue of Liberty lah. Right, so brass, okay, it is used to make your key. Your key is brass. If you use your key for a very long time, the thing will turn from silver to yellow. What is the silver? The silver is actually the coating. Once you use your key for a few years, when the coating is no more, you will see the underneath color, which is yellow. That's your key lah. So your doorknob, your musical instrument, your trumpet, your trombone, your tuba, your French horn, okay, even saxophones, okay, they are made from brass. Okay, shiny and yellow. Okay, so duralumin, you don't need to know what is this. Okay, the main ingredient is aluminium, okay, it's duralumin. So they are light and strong. Okay, this is used to make aircraft. Okay, your aeroplanes are made from duralumin because you would want your aeroplane to be lightweight. So this is why you use aluminium. Okay, so what is a superconductor alloy? This one just read for fun, not common in exam. So this is some alloys, they can become superconductor. What is the meaning of superconductor? They are much better than conductor. They are practically zero resistance. Okay, so they can make very strong magnets. Very strong magnets. So you use it only in two places, which is your magnetic levitation train, your bullet train, okay, and your magnetic resonance imaging, which is your MRI. You know what is MRI, right? The machine you sleep inside to scan for cancer, to scan for tumor. That's your MRI. So both these cases, they use magnet. That's why we use superconductor alloy. Okay, not really important. This is more of a read for fun stuff. All right, so let's look at explanation. This part is very common in exam. They will ask you what makes pure metal and alloy different. Okay, the difference is the sliding of the atom layers. Okay, the sliding. So pure metal, they are very soft because the layers of atom, they can slide over easily. Please memorize this. Okay, lapisan atom menggelongso dengan mudah. Easily they will slide, so it makes them very soft. But for alloy, when you add something foreign to it, it kind of blocks everything. So now can this atom slide? No, they can't slide because there's something blocking them. Okay, so the atoms, the layers of atom cannot slide. Tidak boleh menggelongso. This is why alloy is hard. Harder than pure metal at least. So this is how you explain. And you need to learn how to draw them. I mean, this is pretty much common sense. All right, so let's look at the two experiments here. These two is going to come out in your section C if they do. Okay, this is your experiment. So if you still remember this, this experiment, I've mentioned this plenty of times. Last year I repeated this. This year I repeated this, and now I'm repeating it again. So what is this experiment? Basically, you put your block here, you put a steel ball here, you put a weight here, and then you release the weight. You crash, you bang the weight onto the ball, and the ball will create a dent at the metal. Okay, so you use a copper here. Okay, you can use a bronze. So you can see what we are trying to measure is the dent. Okay, the lengkokan. how deep is the dent. If you look at copper, okay, you see this thing is bigger, average 4.3, where if you use bronze, this is only 3.1. So what does it mean? It means bronze is harder. The dent is smaller. Okay, if your metal is very soft, I punch your metal, I'm going to see a hole. I'm going to see a dent. If your metal is very hard, I punch it, and the dent will be smaller. Okay, common sense lah. This is, if they ever come out experiment for alloy, this is the one coming out. Okay, most likely. And then the next one is the corrosion one. Now this one is about hardness. This is about corrosion. Basically, you just take water, you put iron, you put steel. So what will happen? The iron one will rust, brown layer. The steel one will not rust. There's no brown layer. Take note, please write brown layer. Please do not write rust. Do not write karat, do not write rust. Why? Because whatever you see, what you see is brown stuff. Brown is not necessarily rust. I know in this case it is. But sometimes your teacher might pick on mistakes like that. They say, oh, what you see is brown. What you see is not necessarily rust. So rust is not accepted. Okay, you don't know it is rust until you further test it out. You see, because, why do I say this? Because one of my students kena this before. Okay, he wrote rust in exam, the teacher gave him wrong. Okay, she say in observation, you should say what you see. So in this case, it's brown layer, lapisan perak. Okay, stupid mistake like that, they can catch you for that. Okay, so this is the experiment. Okay, next, glass and ceramic. Again, like I said, this part not common in exam. I wouldn't want you to focus. Focus, I mean, read this if you have extra time. Because this glass and ceramic, like I said last year, this is a new part from chemistry. Last time, this thing used to come out in chemistry. So they pull it down to science for you to study. So just read this for fun. Okay. Generally, you can know this, but don't focus. All right, so what is glass? Glass is made from silica. Okay, silica is basically sand. Okay, the scientific name for silica is silicon dioxide. Okay, it contains silicon and oxygen. Okay, so silica will melt at 1005, and when you melt them, you cool them down, you will form glass. As simple as that. So you have 4 types of glass here. You have the typical glass. Okay, the most common type of glass is called fused silica glass. I don't know what is it called in BM again. Kaca what is fused? Tercantum, tergabung. I don't know what is it called. Okay, kaca something. Okay, so this is the most typical glass. Your fused silica glass only contains nothing but silica. This is the only thing that is inside. When you use sand, pure sand, you add nothing to it, you will get this glass. Most type of glass is this. Okay, I have an IKEA bottle here. This is just a fused glass. Okay, very typical. As you can see, they're very thick. Most fused glass, they're very thick. So what makes this so good? What is the good point about silica? They are resistant to heat. They can tahan a lot of heat. That's why you put hot stuff into glass, they are usually fine. You cannot do this to plastic, but you can do this to glass. They are chemically inert. Nadir secara kimia, stabil secara kimia. They will not react with anything. You put curry onto it, you put durian into it, you put anything strong smelling onto glass, you wash it, the smell is not there anymore. Plastic is different. Plastic will kind of absorb that smell. Okay, that's why your tapo is very hard to wash. Okay, so this is the most typical glass. Okay, now we have the weaker version and the stronger version. Okay, and the reflective version. This is not for container. This is for light one. These 3 are used to make container. So if let's say you are using glass, okay, glass is very thick, right? But now you say, I don't want such a thick glass. I want a thinner glass. I want a weaker glass. So this time you would use a soda lime glass. This is called kaca natrium kapur. Okay, natrium kapur. So the composition, you can read this yourself. Don't focus. So they are low melting point, easy to shape. The main point here is easy to shape. Senang dibentuk. But the weak point is they are very weak. This soda lime glass, don't use force because this thing will break very easily. Okay, case in point, for example, last time McDonald's used to give out this free Coca-Cola glass. Not sure you have this at home. Okay, that Coca-Cola tall glass. That thing is for sure soda lime because it's so weak. Why do I say so? Because one day I was washing it after drinking. I accidentally bang this thing onto the wall, the thing cracked in half. Okay, just a normal tap. Okay, not really a tap lah, but it's just a normal bang on the wall. This thing cracked very easily. That's why I say this soda lime glass is a very weak glass. Where do you use it? Use it in light bulbs. Okay, light bulb has very thin glass. Okay, light bulb is not a container. You don't need such a thick glass because their job is just to shield the thing to prevent you from touching, you know, because it will burn you. So you just need a very thin glass. So we use it in light bulb, soda lime glass. Okay, this is the cheapest glass you can get. Okay, next one, the stronger version. Okay, say if you want fused glass, but you want a stronger one. Let's say now you're handling strong acid in the lab. You're handling strong alkali. You're handling strong stuff. You would use a borosilicate glass. Okay, you see, just now fused is resistant to heat. This one is high resistance to heat. They are very tahan harbor. Okay, compared to soda lime. Okay, so you use it in your laboratory apparatus. That means your conical flask, your measuring cylinder, your pipette, burette, and so on, they are all made from borosilicate glass. This is why lab equipments are expensive, because they use high quality glass. Okay, some glass you get for your kitchen, okay, some containers they are also made from borosilicate. That's why if you buy kitchen stuff, if you buy from Mr. DIY, glass from Mr. DIY is usually very cheap because they're just fused glass. If you buy from branded stuff, okay, if your plates are glass and they're branded, most likely they're borosilicate. They're much harder and they last longer. All right, so the last one, lead crystal glass. This is not for container. The main job of this thing is high refractive index. They are for refracting light. If you have a chandelier, you would use this glass, okay, your lead crystal glass. The function is just there to reflect light. That's all. Okay, so 4 types of glasses here. Okay, so next let's look at ceramic. Ceramic is very easy. Ceramic is only one type. There's no few types of ceramic. They are made from clay. Okay, so here's the difference. Glass is made from sand. Ceramic is made from clay. Sand and clay, they are somehow the same. What the difference is, sand is rough. When you take sand and you rub it between your finger, sand is very coarse and rough. When you take clay and rub it between your finger, they are very fine. They are silky smooth. Basically, it's a size difference. Sand is very big. If you zoom in, sand looks very big. If you zoom into clay, clay looks very small. They're very fine. So that's the difference. So when you use clay and you do the same thing, you heat them, you shape them, and then you cool them down, you get ceramic. Okay. So that's a ceramic. And then they are made from aluminium silicate. Okay, aluminium, silicon, and oxygen. All right, so properties, they can stand high temperature, they're very hard, they're brittle, okay, same as glass, they're very brittle, chemically inert, they will not react with anything. That's why your ceramic glass, your ceramic bowl, your ceramic plates, even after 20 years of using it, they are still brand new, right? I'm sure you use ceramic stuff in your home, you use it to eat. Your ceramic plate, even after 20 years of using it, they are still shiny. Okay, they still do not stain. If your plate is white color 20 years later, no matter how hard you use it, I think it will still white. Okay, that's a good thing about ceramic. Right, so they are good insulators of heat, good insulator of electricity. Okay, so in your furnace, you line it with ceramic. In your toaster, you use it as an insulator. Okay, because the side of the toaster is very hot, so they will put ceramic there to stop it from melting. All right, so properties difference. Glass is transparent. Okay, ceramic is opaque. That means the gap light cannot go through. Melting point, glass is lower, ceramic is higher. Ceramic, although both are high, okay, both has high melting point, but ceramic is higher. That's why they're more stable. So result of heating repeatedly. The good point about glass, it can be repeatedly heated. You can heat glass and you shape it anything you want. You can repeatedly do this. Ceramic, no. Once you shape ceramic, the thing is already like that. If you break it, the ceramic is rubbish now. It is trash. You cannot recycle ceramic. Okay, so that's the bad point. All right, so next one, let's look at your polymer. Now this one focus on the rubber, okay, which I think I'll talk about rubber next week. Okay, so what's a polymer? Polymer is a chain of monomer. When you combine a few, mono is one. When you combine a few monomer, it becomes a polymer. For example, glucose. Glucose is a single sugar. When you combine many glucose, you will get starch. Okay, starch is a few million units of repeating sugar. Same goes to amino acid, you get protein. Isoprene, you will get natural rubber. Okay, so let's look at synthetic polymer. These just now, those are natural polymer. You can find it naturally. But synthetic polymers, okay, man-made ones, for example, polythene. This is the cheapest plastic. Your plastic bottle, plastic bag, any plastic stuff, your basically packaging plastic, they are all made from polythene. All the single-use plastic, you go tapao, all the plastic they use is polythene. Okay, this thing cannot tahan heat one. So please don't buy any soup stuff from, if you tapao soup from outside, please use your own container, because if not, they're going to pour the soup inside the plastic. You are going to drink plastic, my friend. Okay, so if you don't want plastic in your body, then bring your own container. Okay, bring glass. Okay, just be careful. All right, so styrene, polystyrene, you know what's this lah? Your packaging material. When you buy new TV, that white color stuff, that's the polystyrene. We used to use this to tapao stuff also, but somehow the government banned it because this thing is very hard to recycle. Okay, so perspex, this is used to make your, okay, what is perspex? Perspex is that clear plastic, okay, that clear hard plastic. In US, they call it acrylic. Okay, acrylic. So where is this used in? You know, if you go to some restaurant, they will put the transparent shield, right, for social distancing. That transparent shield is perspex lah. Okay, basically it's transparent. Okay, use it to make your aeroplane window. Okay, even your windows for vehicles. And then synthetic rubber is your neoprene. Now this thing is your, you use it to make your diving suit. You know, when people go scuba diving, they will wear that black color tight suit. Now that's neoprene. All right, so the last part, what is polymerization? To change monomer to polymer, to join them together like this. Okay, monomer joined to polymer is called polymerization, polymeran. The reverse is called depolymerization. D what? Nya polymeran. Okay, so that's pretty much it for today. Okay, so let's go to our exercise. Yeah, I'll try to focus more on exercise today. Right, so let's look at section A. Let's go to page 16. Okay, page 16. So diagram below shows an experiment to study the resistance towards corrosion of pure metal compared to alloy. So you have water here, you have steel nail and iron nail. So write down the observation. So I said just now, don't write rust. Okay, so for the iron nail, you will see brown layer. Okay, brown layer is formed. Lapisan perang terbentuk. And for the steel nail, no brown layer is formed. Okay, finish yourself. The other lapisan perang terbentuk. Okay, complete the sentence yourself. It's just repeating sentence. So state the hypothesis for this experiment. Okay, what can you guess from here? In this case, you can write rust. Okay, because you're trying to guess what you don't know for sure, but you can guess. So iron rust in water, steel does not. Okay, besi berkarat di dalam air, beri tidak. Okay, it doesn't rust. Okay, so next, C, if the experiment is carried out for 1 week, predict the condition of the steel nail. Okay, so it remained unchanged. The other, perubahan, because steel will not rust. So to say won't rust, maybe you can see a little bit of rust. Steel, they will still rust a little bit. Unless you're using stainless steel. Stainless steel just won't rust. Okay, that's why your cutleries, they are made from stainless steel. Okay, because they don't rust. Okay, so D, state the operational definition for alloy based on this experiment. So what is operational definition? Again, remember, this is section A. Section A is where you will see observation, all the experiment stuff lah, observation lah, hypothesis lah. Okay, and okay, so what is operational definition? We know what is definition. Definition means meaning. So what is the definition for alloy? Alloy is a mixture of different metals, but they don't want. They want operational definition. That means you have to write your definition based on what you see. So which is the alloy here? Steel is the alloy, right? So what do you see here? No brown layer is formed. There's no brown layer. So what is alloy based on the observation? So alloy is a type of metal that does not form brown layer in water. Okay, it is a type of substance that doesn't form brown layer because this is based on what we see. You have to write the definition based on what you see, not your normal definition, not your definisi biasa. No, okay, you need to write based on your observation. So alloy adalah sejenis logam yang tidak membentuk lapisan perang di dalam air. Okay, it doesn't form a brown layer in water. Okay, so mark the arrangement of atom in steel nail. Steel is alloy, right? So it should be this one. This is pure metal. This is not related to even this one. This is just ion. Okay, what we learned last week. Okay, so moving on. Yeah, moving a bit fast. Okay, if you need me to slow down, let me know. So number 2. Why is this the same question? Okay, so what is the function of sodium chloride solution? It is to cause metal to rust. Okay, menyebabkan pengaratan logam. You know what? I think I'm going to skip this question because it's the same thing. Predict the observation. Same. This one will no brown layer. This one got brown layer. Inference because steel will not rust. Iron will rust. Operational definition of alloy. Alloy is a substance that doesn't form brown layer. Wow, exactly the same question. Okay, you know what? So let's skip. Okay, this is the typical question. So when we put copper here, when we smash the weight down, this is the dent. When we put bronze, you see the dent got smaller. Why? Because this bronze is harder. So A, by using a ruler, measure the diameter of the dent formed on the block. Okay, this one I cannot do for you. You measure this yourself. Okay, because my size and your size is different. My size on this paper. Measure this yourself. Just use ruler. So state the variables. Okay, MV, what are you trying to change? The only thing you change is this one. Okay, which is the type of block. Okay, jenis bongkar. Okay, listen, you only have one MV. Every experiment, you only try to change one thing. The rest of it doesn't change. So your CV has many. Now, what you don't change here, the size of this block, okay, the steel ball you don't change, the weight you stay 1 kg, the height you stay the same, other things you make it the same. Okay, so in this case, the mass of weight. Okay, jisim pemberat. You don't change the weight. You don't want one you put 2 kg, one you put 1 kg. Of course, it's not going to be accurate. Okay, every experiment, you only change one thing. You don't change 2 things because it's going to affect the result. Right, this is the basic of experiment you should know. Right, so what is the conclusion for this experiment? Okay, what can you conclude from here? You can say, what was used again? Bronze and copper, right? Okay, so bronze is harder than copper. Okay, gangsa lebih keras daripada kuprum. All right, so next, number 4. Diagram below shows an experiment. Why is it the same question again? Goodness me. Okay, you know what? I'm going to skip this. It's the same question again. Basically, smashing the weight. Look at the dent. I see copper more deeper than bronze is shallower than. Same thing. Okay, so skip this. Oh, operational definition of alloy. So what is alloy? Bronze is the alloy, right? Alloy is the smaller diameter of the dent, right? So this one, right answer for you. Okay, alloy. Okay, alloy is a type of metal that produces a smaller diameter of dent. Okay, sejenis logam yang hasilkan diameter lengkukan yang lebih kecil. Okay, you get a smaller dent. Right, so like I said, it's based on what you see. Right, your operational definition is based on what you see. Okay, moving on, let's go to number 5. This one I think is almost the same question too. Okay, because this is hardness also. When you hammer copper, the thing bends. When you hammer bronze, there's no change. This is hardness also. So state one observation. Okay, you can say copper bends after hammering. Okay, bronze does not. Okay, cuprum bengkok selepas ditukul, gangsa tidak. Okay, one inference based on what you see. Inference is explained because bronze is harder than copper. Write it yourself, it's the same answer over and over again. Okay, bronze is harder than copper. So one hypothesis, it's almost the same as the inference, but you can change it a little bit. You can say alloy is harder than pure metal. Okay, alloy lebih keras daripada logam tulen. Okay, I'm changing a little bit because up here I'm using bronze and copper, so I don't want to repeat the same answer. So state the constant variable. What is the thing that you don't change? Okay, the size of the rods. Okay, size rod. You have to use the same size. If it is different size, then very hard to compare. You can say same force of hammering. You have to hit the rod at the same force. So based on the experiment, state the operational definition of pure metal. So this time they want pure metal. So pure metal is a type of metal that bends after hammering. Okay, sejenis logam yang membengkok apabila ditukul. Okay, when you hit it, it bends. That's pure metal. Okay, moving on. Latex, I'll leave it for next week lah. Okay, let's go ahead. Let's skip ahead. So let's look at question 7. Okay, this is section B already. In section B, this is the part you need to study. You don't study, you cannot do one. So section A will ask for all those observation lah, and whatnot. This one will not. You will not see those observation whatever hypothesis here. Okay, because that is not what they ask here. That is section A. So question 7A, based on the tables above, name alloys P and Q. So what is P? P is copper and zinc Okay, so P should be your brass. Okay, loyang. And Q should be your bronze. Answer. Now, what did I say again? You see, it's always these two metals that they will ask you. Bronze and brass. Okay, the cousins of copper. So what is the foreign atom in steel? Now steel, which is the foreign? Foreign is the last one. Okay, the more is the main one. Okay, carbon is the foreign. Okay, they are just there to make this thing harder. They are not the main ingredient. So name the process involving in making alloy. That would be your alloying. Okay, alloyan. So compare between pure metals and alloy. So I said this already, right? Just now, alloy is harder. Okay, more resistant to corrosion. Okay, lebih keras, lebih tahan hakisan. Okay, this one you write yourself lah. Basically, you can say alloys are harder than pure metal. Alloy lebih keras daripada logam tulen. Alloys are more resistant to corrosion than pure metal. Alloy lebih tahan hakisan berbanding dengan logam tulen. Okay, so number 8. Diagram below shows the process of making brass. So, okay, so you have your main metal and your foreign metal. So who is main, who is foreign? You have to ask yourself, who is the main guy? Okay, that will be copper. And zinc is the additional guy. They are not the main character. They're just the supporting character. That's why we call them foreign metal. So for P and Q, now you see P is the one that is the most in the metal. You see a lot of P here. So obviously P is the main character. So P is copper. Q is zinc. Okay, so B, give the composition of each metal. If I'm not mistaken, this is 75%, 25%, but you don't need to know. Don't memorize the percentage, you're wasting your time. Guys, give me a few minutes, there's something I need to collect. Okay, I'll be right back, give me 5 minutes. Okay, sorry for that. Let's continue. Okay, so let's look at C, name the process. Okay, mentioned this already lah, alloying. Okay, pengalloyan. So D, what is the effect of presence foreign material in alloy? Okay, so what's the function of this thing? This is to prevent the atoms. Okay, so what do? They will slide, prevent the atoms from sliding over. Okay, menghalangnya daripada menggelongsong. Okay, the keyword here is menggelongsong. Okay, menghalang atom daripada menggelongsong. antara satu sama lain. Okay, whatever. Okay, you see the questions are, they are repeating one. It's the same answer over and over again. All right, so question B, question 9. Okay, two objects here. The type of alloy. So P is brass, okay, because it's the yellow one. Q, this one, it doesn't look very nice, but this should be bronze. Okay, the answer. So again, brass and bronze, is it always these two? So B, give two other uses of the alloy used to manufacture P and Q. So brass, besides making musical instrument, what can they do? You can use to make your keys. Okay, kunci. You can use it to make brass. What else can you make? Brass. Okay, doorknobs. Okay, your door. I don't know, is it called BM? Okay, and then Q, brass. Bronze. You can use it to make coins. Okay, duit shilling. You can use it to make monuments. Okay, monument is the tugu lah. You know, tugu negara. Some building, some structure you use to commemorate a certain event. That's a monument. Okay, your tugu negara basically. So C, why is a bronze block stronger than a copper block? This is the same answer over and over again. Okay, so for copper, let's explain copper first. So atoms, wait, not atoms, layers, I keep forgetting layers. Okay, layers of atoms of copper slide over each other easily. Okay, again, menggolongso, I'm not going to write BM, you write it yourself. Lapisan atom kuprum menggolongso antara satu sama lain dengan mudah. Whereas for bronze, okay, you can say bronze contains foreign atoms. Okay, foreign atoms mengandungi atom asing. Okay, so it prevents sliding. Prevents the atoms from sliding over each other. Mengelakkan. Okay, mengelakkan menggelongso. Okay, excuse me. Right, mengelakkan atom daripada menggelongso antara satu sama lain. Same answer lah. I'll be repeating myself again and again. So, in your opinion, can the alloy which is used to make object P be used to build a ship? Explain your answer. So, can you use brass to build a ship? Yes, you can. Explain your answer. Because it is resistant. Now, basically, what is the characteristic of alloy? They are resistant to corrosion. Okay, tahan hakisan. Basically, you can use brass to build a ship. But would you? No. Why? Because it's very expensive. It's very expensive. We would use steel because steel is much cheaper. Yeah, steel will still rust. This is why they have to paint the shape. Okay, steel will still rust. Not to say steel won't rust. They are alloy, but it still rust. That's why they paint it. They will paint the shape. You wouldn't use brass because it's too pricey. I mean, it wouldn't make any sense if you overbuild something. All right, so next, number 10, name the major component of glass. That would be silica. Or the scientific name, silicon dioxide. Okay, you can write either one. Where can silica be found in nature? Sand. Pasir. Name the element found in silica. So we know silica is silicon dioxide. So we have silicon and oxygen. Dioxide is oxygen, right? So silicon and oxygen. So 3 properties of glass. Easy lah, it is transparent. Okay, Lucina. It is brittle. Rapuh. Okay, the thing can crack easily. You can say it has high melting point. Okay, high melting point. Takat, lebih tinggi. Okay, high melting point. All right, so next, why is the main component in both glass and ceramic? Okay, circle the correct answer. That would be a silicon dioxide. Okay, moving on. Number 11. Photograph below shows the laboratory apparatus made of glass. Okay, what type of glass is used? Okay, what is this? These are lab equipments. You would want the strongest glass. So what is the glass used? That would be your borosilicate glass. Wait. Yeah, borosilicate glass. Kaca, borosilicate. You can use fused glass, no problem. But fused glass is cheaper lah. It's cheaper. If you want really good quality, you would use borosilicate because this thing won't stain for years. This thing will stay very clean. Okay, so B, how is the type of glass you stated in question A selected in the manufacture of the above product? So why choose this? Why choose borosilicate glass? Because it has high resistance. Okay, high resistance to chemicals. Oh wait, not chemicals, heat. High resistance to heat. Okay, sangat tahan haba. Or you can say they are chemically inert. Can also. Stabil secara kimia. Okay, they're very stable. They won't react with anything. They won't stain anything. So no matter what strong acid or strong alkali you use, they're going to stay, unaffected. Okay, C, give example of another type of glass that may be suitable in producing the above product. Explain your answer. So what else can you use? Like I said, you can use a fused silica glass, which is the most typical glass. Okay, kaca, what is it called? I don't know. Sorry, yeah, I don't know. I forgot what's the name of this glass already. So explain your answer. Okay, because it is same thing. It is resistant to heat or chemical. Okay, it's basically same answer as this. It's just that fuse is not as good. They're still good. It's not as good as borosilicate. If you are just using it for, you're not using any strong chemicals, you can use fused silica, no problem. It's just that borosilicate is much better. It's up to you lah. So D, is the glass used to make the product above suitable to make drinking water containers to be used in the restaurant? Justify your answer. Yes. Okay, because they are resistant to heat. Okay, tahan haba. That's why in restaurant you will use glass because that thing would last for a very long time. You wouldn't, easy to wash. Okay, because it doesn't react with any food. And this thing can last for a very long time because it can stand heat. You can use it to put any hot stuff you want, hot drinks you want. I think it's not going to break down over time. Okay, easy, Okay, like I said, this glass and ceramic part is even easier, so I wouldn't focus here. It is what it is chapter. What you read in the textbook is what is coming out. Okay, there's nothing really much to say. Okay, so number 12. So a bowl of ceramic. So what is the main component in clay? Okay, very good question. That would be your aluminium silicate. Okay, it's mentioned here. Aluminium silicate. It's slightly different from what was it again? Silicon dioxide. Okay, slightly different. So referring to the figure above, state the advantage and disadvantage of ceramic. Okay, the advantage is it is resistant to heat. Basically, it's the same as glass. It is resistant to heat or chemical. Okay, tahan haba or kimia, bahan kimia. But the disadvantage is it is brittle. This thing can crack easily. Okay, and you can even say this thing is hard to recycle. Ceramic cannot be recycled, cannot be reshaped, cannot be reheated. Tidak boleh dileburkan semula. Tidak boleh dikita semula. Whereas glass you can recycle. Glass you can just, when you break glass, you just sweep it off. Okay, you reheat the thing, you can just remake a plastic a glass bottle out of it. But ceramic, no. Once you break it, it is rubbish. So there, see, mentioned here already, ceramic cannot be recycled like glass. Why? Okay, because glass can be reheated and reshaped. Okay, boleh dipanaskan dan dibentuk semula. Okay, ceramic cannot. Okay, I'll be reshaped lah. Write this yourself. Ceramic tidak boleh dipanaskan semula. So state two other uses for ceramic. You can use ceramic for to make bricks and tiles. Okay, membuat tiles is ceramic untuk membuat jubin. You can use it as an insulator in toaster. Okay, toaster is the bread toaster. Or you can use it in the insulator in your spark plug. Okay, you know what's a spark plug? Spark plug is your what do they call this in BM again? Spark plug is called palam pencucur. What is that thing? Spark plug is the thing in your engine. Go and ask your dad, he would know. Okay, you know. There's a thing in the engine that makes fire that causes your engine to run. The thing is called spark plug. You have to change it every 2 or 3 years. You ask your dad, he would know. All right, so E, match the glass and ceramic with the correct use. So glass is to make glassware, okay, and lab apparatus. Ceramic is for bricks and cement, and insulator for electrical appliances. So basically, the two functions already mentioned here. All right, so next F. A student was dazzled by sunlight when her doing school in her room. She wanted to change her window glass to solve the problem. So what can she use? Like I said, there's only one type of glass that can refract light. That would be my lead crystal glass. Okay, this is used in your glass bottle. This is a stronger one used in lab. This is the weaker one used in your McDonald's glasses. Okay, these three are containers. Okay, they have nothing to do with light. Okay, sunlight is when we need to refract light away. Okay, that's when I use the lead crystal glass. All right, so you know what? I think I'm gonna stop here today. Okay, I will finish the rest next week. Oh yeah, by the way, next Saturday there will be no class. Okay, I won't be around next Saturday. So please choose other slots and replace your class. Okay, sorry for that, because there's a wedding in my family. Okay, I have to attend and I will not be available next Saturday. All right, so take note. I will see you again next week. All right, so happy Saturday to you all. I will see you next week. All right, so take care. See you next week and bye-bye.